What would it be like to live on a different kind of tidally locked planet? So in the last video we talked about what tidally locked planets are and really broke down what it would be like to live on one in which only the Terminator zone was habitable while the rest was a scorching desert and an icy tundra. But that's not the only option for a tidally locked planet. One of the key things that determines the topography of any planet is how much water is on the surface. Water content determines things like the formation of an atmosphere and what kind of life forms can survive, but the key thing that we're going to focus on here is its role in temperature management. A planet covered in mostly water is going to distribute heat more effectively than one with less water because humid air transfers heat differently than dry air. So if our tidally locked planet is like Earth in that it's about 70% covered in water, instead of becoming a desert, the side facing the sun would more likely be a jungle. It would be very hot but also very humid, and most if not all of it would likely be habitable. The dark side of the planet would still be freezing cold, but the warm, moist air from the light side would carry heat further into it, meaning not quite as much of it would necessarily be frozen over. Therefore, some of this side of the planet could potentially also support life, albeit with some challenges that I'll get into in a minute. A lack of biodiversity and different ecosystems would not be as much of a factor on this planet as our last planet. The warm side would likely be similar to the equator on Earth and could contain jungle, rainforests, and possibly even deserts. As we approach the Terminator zone, we'd find more temperate regions, and towards the back, eventually we'd find permafrost, tundra, ice, and snow. But don't make your tidally locked planet too Earth-like, because the lack of a day-night cycle would dramatically affect the vegetation that develops on this planet. On Earth, plants are engineered to gather energy during the day and use stored energy at night. On a tidally locked planet, the constant exposure to UV light would give them boundless energy, but they'd have to be engineered to protect themselves from overexposure and burning. In fact, dealing with near constant exposure to the sun would affect how nearly every life form on this planet developed. Their only relief from their ceaseless and unmoving star would be clouds and shade. Now, shade would be a little bit interesting on a tidally locked planet because shadows wouldn't move like they do on Earth. And this might seem like an unimportant detail, but think about what that would mean for vegetation. Once a tree, let's say, starts growing, the area on which it casts its shadow will be in shadow forever unless that tree gets destroyed. As that tree grew taller, any plants that couldn't in some way extend themselves outside of that shadow would probably die, and the area behind the tree would be a growing dead zone. This would mean that fast-growing planets would have a significant advantage over slower-growing ones. Perhaps you'd see more vines, climbing plants, and plants that prioritize growing horizontally and maybe are able to abandon sections of themselves that fall into shade. Perhaps you'd see more plants that tap into one another's root systems for nourishment, and parasitic or carnivorous plants that aren't even optimized for photosynthesis. Agriculture on this planet would have to be carefully planned to ensure that everything your fictional civilization wanted to cultivate would get the light it needed. Perhaps they'd use mirrors and reflection to counteract the shadows that might otherwise loom over their gardens and farms. I would have to imagine this would impact their city planning as well. If your fictional civilization was as prone to classism as humans are, there would probably be some cultural significance to having a home that was bathed in light or shadow, and frankly it's just as possible that either could be considered an indicator of status. Either way, they would almost certainly be very conscious of what permanent shadows were being created by every structure they built. Another interesting thing about steady shadows is that they could be used to navigate. While not terribly useful where the sun stayed directly overhead, in many places you could ensure you were oriented correctly by comparing the angle of your movement to the shadow you cast. Once the civilizations on this planet began to travel great distances, they'd undoubtedly become aware that in some areas things cast shorter shadows while in other areas they were longer, and that those shadows seemed to angle in different directions. This would almost certainly have an impact on their mythology and how they grew to understand geography and the shape of their planet. Perhaps the area directly beneath the sun would be considered holy or cursed. Interestingly, a stable sun might lead them to the conclusion that their world was a sphere very quickly. It could even make determining the circumference of that sphere less complicated than it was for early mathematicians on Earth. All this would be a big deal for the light side of the planet, but let's talk about the dark side for a minute. With the overall temperature of the planet being more moderate, it's possible that more of the dark side of the planet could contain liquid water and could be survivable temperature-wise, but the lack of light would still cause issues. If life did develop there, it would likely look very different from anything we're familiar with. Plants form the basis of most food chains, and on Earth we don't have any plants that can survive with no light. They all need at least a little sometimes. So if you wanted to put plants there, think about where that energy would come from instead. Perhaps there could be a compound in the soil that could support a totally different type of plant that didn't need to photosynthesize. These plants likely wouldn't be green. Maybe they develop deep, complex root systems and grow very little mass above the surface. Alternatively, perhaps plants wouldn't be the basis of the food chain at all. You could invent something totally different. Whatever the case, keep in mind that if you want large, scary predators there, they're going to need smaller animals to eat, and if those animals aren't herbivores, they're going to need to eat even smaller ones. So as fun as an icy tundra with gigantic monsters and nothing else is, if you're looking for more realism, think through the whole food chain. A civilization that developed on that side of the planet would likely have very different physical properties to the light side civilizations. They would likely need to be able to see in the dark and quite possibly would have little to no tolerance for sunlight. Perhaps their bodies would be built to retain warmth where the light-side civilizations would be better served by bodies that could shed it. As the world developed, the two civilizations would undoubtedly encounter one another eventually. Think about how they'd react to one another's difference. Would they even recognize each other as the same type of being, or would they find each other monstrous? Alternatively, if you want exploration onto the dark side of the planet but don't like the idea of building out an ecosystem that makes sense there, think about what resources could drive a light side civilization to explore that side of the planet anyway. In our last video, we talked about the dark side being the only place to see stars and gain a deeper understanding of the universe, but alternatively, they could journey there just to mine or harvest something. Maybe they use it for punishment or imprisonment. So for the sake of simplicity, when exploring both of these planet options, I've been acting as though they didn't have any moons, but moons would absolutely make things interesting in ways that I actually want to dedicate an entire video to, so stay tuned for that. I'm gonna end with my usual disclaimer that we are embracing hypothetical on this channel and exploring a lot of territory that we frankly know very little about. I know I gloss over a lot of the science in favor of exploring interesting ideas, but if you have questions, drop them in the comments and I will do my best to answer them or direct you to other resources. They may even become the topic of another video series, and I can't wait to see y'all in the next one.